In this problem, we're looking at the rational function of 10x squared divided by x minus 5. And this function is top-heavy, meaning up in the numerator, my significant figure that I'm looking at is 10x squared, and in the denominator, it's x to the first power. So the numerator has greater power than that denominator does. Because it's top heavy, there is no horizontal asymptote, and again, top heavy. We'll come back to the slant asymptote in just a second, but for a slant asymptote, the degree of the numerator has to be exactly one more than the degree of the denominator. So we are going to test for a slant asymptote in a bit. For the vertical asymptote, we're just going to set the denominator of x minus 5 equal to 0. And when you solve that thing, you get that x equals 5. So that will be our vertical asymptote. And for the slant asymptote, we're going to say 10x squared divided by x minus 5. And let me do something real quick. I'm going to do long division, and that's a square root sign. Still looks like a square root sign. Okay, for long division, I need placeholders. I just have a monomial on the top, and it's 10x squared. I want it to have an x to the first power, and then nothing at all, an x with a 0 power. I still need that order there, and I still need placeholders. So now I'm asking myself, what can I multiply this x by to get 10x squared? Well, you could multiply it by x, or 10x rather. Okay, and if you say 10x times the x, you get 10x squared. And then if you say 10x times the negative 5, you get negative 50x. And what you want to do at this point is put parentheses around it and subtract. You get 0 right here, and then you have to say 0 minus negative 50x, which is a positive 50x. So now we're saying, what can I multiply x by to get 50x? And you can multiply it by 50. So 50 times x is 50x, and then 50 times negative 5 is negative 250. And we're going to put parentheses around it and subtract. So we get 0 right here, and right here we get 0 minus negative 250 is positive 250. But since, let me fix that. Since there's nothing else to bring down, as in over here, 250 is our remainder. And that's why it's important to have these placeholders so you can see when you're done. So the slant asymptote will be at y equals 10x plus 50. And we're not worried about that remainder for that slant asymptote. Okay, now at this point, a lot of times your questions will be multiple choice. So it's kind of like a process of elimination. The first thing that I would do on my scratch paper, I would kind of plot those asymptotes. So there was not a horizontal asymptote, but there was a vertical at x equals 5. And our slant asymptote was at, let me fix that real quick. Our slant asymptote was at 10x plus 50. So for our y-axis, we had had a y-intercept of 50. So let's just pretend this is 50 right here. And then if your slope of that slant asymptote is 10x, let's just, for scratch purposes, say that it's a positive, that this is a positive 10 slope. Now, if we had the correct ratio as far as counting by, ones or twos or whatever, we would go up 10 and over 1. But that's just an idea of where your asymptotes are at. So what you would want to do at this point to graph the function out, you could choose x and y values. And I want to choose x and y values on both sides of that vertical asymptote. So maybe an x value of -1 and 0 and +1. And see, that's looking at this side of that vertical asymptote. And then x values to look at this side of the vertical asymptote could be, let's see, 6 and 7 and 8, okay? And from there, process of elimination. You don't have to, especially if it's a multiple choice question, you don't have to check every single one of those points as long as it's going through and making true statements.